Now let us see what is acceleration. Acceleration is the rate of increase of velocity of an object is called acceleration. The rate of increase of velocity of an object is called acceleration. What is rate of increase of velocity? Increase of velocity divided by the time interval. Right. Let us see the example. A car is moving at a velocity of 60 km per hour. The driver wants to increase the velocity of the car. He presses the accelerator pedal. So what happens? The velocity increases from 60 km per hour to 100 km per hour. Let it take 5 seconds to reach the velocity of 100 km per hour. So here in this case the acceleration is final velocity 100 km per hour minus initial velocity 60 km per hour divided by time 5 seconds. Therefore acceleration is change in velocity divided by time taken for the change. This is called acceleration. Right. When the velocity is increased to 100 km per hour, when the driver wants to maintain the constant velocity at 100 km per hour, right? Then what happens? There is no acceleration. That is, when the car is traveling at 100 km per hour at constant velocity of 100 km per hour, there is no acceleration. Therefore, acceleration is there only when the velocity increases from one velocity vector to another velocity vector in a particular time period. This is called acceleration. Right. So here the acceleration, the average acceleration A vector, acceleration is denoted by A vector of an object for a time interval del t moving in a xy plane is the change in velocity divided by the time interval. This is the xy plane. This is x axis, this is y axis. This is the xy plane. So the change in velocity divided by the time interval is called the average acceleration. So average acceleration is denoted by A vector equal to del v vector, change in velocity divided by del t, time, change in time. Now let us see this, how the velocity vector is explained. You see the xy plane. This is the object is at point P. The initial velocity is v vector. After time del t1 is the time taken for the object to attain the velocity of v dash vector. Final velocity is v dash vector. The object is at point P1. Therefore, this is the direction of acceleration A vector. Therefore, final velocity vector v dash vector equal to v vector plus del v vector. This is according to triangle law of addition. Therefore, v dash vector equal to v vector plus del v vector. Therefore, del v vector is the change in velocity. Change in velocity can be del v vector equal to v dash vector, final velocity vector minus initial velocity vector. The object has taken del t1 time. The time taken is del t1 to attain the velocity of v dash vector. Therefore, at the point P1, the velocity of the object is v dash vector. It has taken del t1 time to attain the velocity of v dash vector. Here also, the object as it is there at point P2, v dash vector is the final velocity. Direction of acceleration is in this direction. Therefore, here v dash vector, the same triangle of addition here, where v dash vector equal to v vector plus del v vector. The time taken for the object to attain the velocity of v dash vector here, from v vector to v dash vector, here is del t2. This del t2 time is lesser than del t1 here. Here it has taken del t1 time, here it has taken del t2 time. Del t2 time is lesser than del t1 time. Again, in this point, the object is at point P3, final velocity vector is v dash vector. Therefore, v dash vector equal to v vector plus del v vector according to triangle law of addition. So here it has the object has taken del del t3 time to reach to attain the velocity of v dash vector from v vector. Therefore, it has taken del t3 time. So in all the cases, the time interval reduces as it reduces. Here it is greatest, here greater, here it is lesser. Therefore, as del t tends to 0, as del t tends to 0, del v tends to 0, change in velocity becomes 0. Here you see that there is no change in velocity. This is the direction of acceleration, this is the direction of velocity. Therefore, as del t tends to 0, del v tends to 0. Right. Therefore, according to the formula, we can write a vector equal to del v vector divided by del t vector. Now let us write a vector equal to del v vector divided by del t. A vector equal to del t tends to 0. Already we have explained. As del t tends to 0, del v vector by del t. Del into v vector, vx I cap plus vy j cap. Component of velocity along x direction, component of velocity along y direction. Therefore, del vx I cap plus vy j cap divided by del t. Then limit del t tends to 0. Separately we can write like this. Therefore, this del vx I cap by del t, limit del t tends to 0, del vx I cap divided by del t is vx I vector. This limit del t tends to 0, del vy by del t I j cap is equal to vy j vector. Therefore, component of acceleration a vector is equal to vx I vector plus vx dt. So this is del vx by del t. I can write vx by dvx dvx I cap by dt plus dvy vector j cap by dt. Therefore, a vector equal to ax, this dvx I vector, I cap divided by dt is ax I cap plus ay j cap. So this component is called ax I cap, this component is called ay j cap. So this is the acceleration.